In this video, we're going to look at the force between two charges. Okay, and let's look at if we have two charges. So first between two particles, okay? So I have particle A, which has a charge of Q subscript A, and particle B, which has charge Q subscript B. Now, the unit of charge is the Coulomb, capital C. Okay, and this relative to the charge of an electron, the Coulomb is a fairly small amount of charge. So one very large unit. So one electron has a charge of 1.602 times 10 to the minus 19 coulombs. Okay. So that is a very, very small amount of charge. So you need 6 point something billion electrons to make up 1 coulomb of charge. Although that amount of charge quite often exists. And we can see here that if we look at the other thing that matters, of course, is the distance. The further apart they are, the smaller force. So this D here is in meters, okay? Because that's the SI unit. Now, Coulomb's law tells us that the force between these particles is given by some constant K times QA times QB divided by R squared. So here, of course, QA and QB is the product of the charges divided by the distance squared. So that's really D. Okay, the distance here. Okay, that's in meters. And here, okay, the number K is some constant, which is 9 times 10 to the 9 Newton meter squared per Coulomb squared. Okay, it's not particularly important what this number is. What you do see, however, a couple of things. One, notice that this is charge times charge divided by the distance squared. Notice that the 1 over distance squared, this is similar in form to the gravitational force. Okay? The other thing you note is this. If I have two positive charges or two negative charges, then the force is positive. And if the force is positive, they repel each other. In contrast, if you have opposite charges, then positive times negative will give you a negative value of force. And if the force is negative, then what that means is that the particles are attracting each other.